In the 2023 National Math Olympiad, only 11% of students managed to solve this. This puzzle isn't just about numbers, it's a battle of logic, creativity, and determination. Today, let's break it down together. A function f of x satisfies the property. Define a new function g of x as a tenfold composition of f of x, where f of x is applied 10 times. Calculate the slope of the tangent line to g of x at x equals 0. Express as the tangent of the angle formed by the tangent line with the x-axis. Since we need to find the slope of the tangent line, it means that we have to find the derivative of g of x at the point x equals 0. Okay, let's do the problem. So first, let's write f of x plus 1 over x minus 1 equals, what do we have? 1 over x minus 1. Then g of x we have as a tenfold of f of x, where we apply f of x to itself 10 times. We can write it as f of f and so on of f of x. And this process repeats 10 times. So basically we have to take a function of itself 10 times. Let's make a new variable and let's call it variable t, such as t equals x plus 1 over x minus 1. So we do that to make it easier to find the original function. Thus we have, let's multiply left and right side by x minus 1. We'll get t times x minus 1 equals x plus 1. Let's distribute t. We have tx minus t equals x plus 1. Then we have then let's move everything with x to the left side of the equation and t to the right side of the equation. We want to isolate x and solve it for x. So we factor x, we have t minus 1 equals t plus 1. Now let's divide everything by t minus 1. We'll get x equals t plus 1 divided by t minus 1. Since our original function is 1 over x, we want to have expression 1 over x. To do that, we subtract 1 from left and right side of this expression. So that means that x minus 1 equals t plus 1 over t minus 1 minus everything minus 1. And now let's add those two numbers. So we multiply 1 by t minus 1. We have t plus 1 over t minus 1 minus t minus 1 over t minus 1. Now let's subtract two fractions. We have t plus 1 minus t plus 1 over t minus 1. T goes away. We have, as a result, we have 2 divided by t minus 1. Now we can finally write down our function f of t that we were looking for. So why do we need this function f of t? This is our original function that we were looking for. So our f of t would be equal to 1, and then we replace x minus 1 with our expression, which is 2 over t minus 1. Now let's simplify this expression a little bit. So we have t minus 1 over 2. So f of t is our original function that we will use right now to find our g of x. Let's go back to our original notation f of x, and let's write down that our f of x is equal to x minus 1 over 2. So notice that we have f of x instead of our function that were given in the problem. Now let's start looking at the first composite functions. Let's take f of x of f of x. So we substitute x with our function x minus 1 over 2 minus 1 divided by 2. So if we simplify this expression, we'll get x minus 3 divided by 4. So this is f of x. Now let's continue this process and see if we do it 3 times. So what would be f of x? What expression we will get? To find it out, we need to put our x minus 3 over 4 into our original f of x. So let's do that. So x minus 3 over 4 minus 1 divided by 2. So let's simplify that. We'll get x minus 7 over 8. Now let's repeat this process one more time. So we put our previous expression. So when we we calculated the composite of the functions for n equals 3. Now let's repeat it one more time. So we take this expression and plug it into the f of x. So we have x minus 7 over 8 minus 1 over 2. And again, if we simplify this expression, we'll get x minus 15 divided by 16. So this is for n equals 4. Okay, we're almost there. Now what we need to do, we need to identify the pattern, how the expression would look like for n times, if we repeat this process n times. So if you take a look at the expression, we have x minus, then we have 3, 7, 15, which means it's 2 to the power of n, and we have to add 1 to get negative 3, negative 7, negative 15. And in the denominator we have 4, 8, 16, which is again it's 2 to the power of n. Now we have to prove that this expression is true for the next k plus 1 term, because this is our guess and we still have to use the inductive reasoning to show that this expression, the formula that we get, actually would be true for any n. So let's prove that this expression is true for k plus 1 term. So here's our f of f. Again, we repeated k plus 1 times. Then our expression for this function looks like x minus 2 to the power k plus 1 divided by 2 to the power k. Everything minus 1 and everything divided by 2. So what we did, we plug in the kth term to our original formula, and now we have to prove that its equation, this expression, equals to our nth term, but for k plus 1. So let's simplify this. So first of all, let's combine, let's add 1, right? So let's subtract 1. We'll rewrite it as k 2 to the power k over 2 to the power k, everything over 2. And now we subtract 2 terms. We'll get x minus 2 to the k plus 1 minus 2 to the k, or everything over 2 to the k, and again everything over 2. Now the last step is just to combine like terms and do the division. We'll get our x minus 2 to the power k plus 1 plus 1, and everything divided to 2 to the k plus 1. So as you can see, this expression is true for nth and for k plus 1 terms. So that means we were correct in our guess, and we can move forward. So let's rewrite our g of x as x minus 2 to the power n plus 1 over 2 to the power n. So let's factor 1 over 2 to the n. You will see in the next move why we do that. So we'll have 1 over 2 to the x times x minus 2 to the power n plus 1. And now it's easy to take the derivative because the derivative is just the coefficient, which is 1 over 2 to the n. Since the n is a constant, so all the terms in the parentheses become just 1 since we take the derivative. So that means for n equals 10, our derivative equals 1 over 2 to the 10, or 1 over 1024. Thank you for watching. If you found this video valuable, please consider liking, sharing it, and subscribing. If you want to support us in creating even more videos like this, check out our Patreon page. Even a bit of support helps us continue to bring in you the best we can. Thank you again, and we're looking forward to seeing you in the next one.